Yes, hi guys. Today I have to talk about, I'm talking about question number 10th now because we were discussing about up to ninth question I have completed. And what is this all about? How I'm talking about. This is quadrature or area of curves. Okay. In case of Cartesian equations, still we are discussing about Cartesian equations. Okay. So first I have started with Cartesian equations, then I'll talk about polar coordinates or polar equations, and after that parametric equations. Okay. So curve tracing for all these things we have discussed in the previous lecture series, but now I'm talking about areas under these curves. Okay. So areas or quadrature, which is known as, I've defined already in the beginning, okay, of this topic. So in the beginning I discussed about that what is the area under the curve. Okay, the process of finding area under the curve or part of a curve is known as quadrature. So quadrature we are discussing about, and we are discussing about Cartesian equations or Cartesian coordinates, the equations which are in Cartesian coordinates, that we are first discussing about. So up to ninth question I have completed. Very important, the same answer was obtained. Now let me take the 10th question. So 10th question, again Cartesian equations. All these are Cartesian equations. I'll discuss some more questions also in the same topic, Cartesian equations. After that I'll take polar coordinates. Polar coordinates are is a smaller topic, but not smaller, but at least 15 or 16 questions I'll take. Then parametric equations. So parametric equations and polar coordinates or polar equations are is a smaller topic. I mean, they are smaller topics, but this topic is a bigger one, Cartesian equations. Mostly, for example, parametric equations are converted into Cartesian coordinates, and after that they are solved. Sometimes they are directly solved by differentiation, etc. But in case polar coordinates are also sometimes expressed there in Cartesian coordinates, or sometimes they are in polar coordinates itself. Okay, so but Cartesian coordinates or Cartesian equations is a bigger topic. So I'll take more questions in this topic as the topic demands. Okay, as the students have asked me, so solve most of the questions so that they can understand the topic in detail. Okay, so that is the most important topic here. So now let me describe what the question number 10 says. Now question 10 says that show that the area cut off a parabola by any double ordinates is 2/3 of the corresponding rectangle contained by that double ordinate and its distance from the vertex. Okay, so here no equation of the parabola is given, so let me take a simple equation of the parabola. Okay, let the equation of the parabola, here, any parabola can be taken, but the most simpler one or the popular one, let the equation of the parabola be y square equal to 4ax. Okay, this is the parabola, and the equation of the ordinate, it says double ordinate, and a parabola by any, and let the equation of the double ordinate be, let x equal to b here, the breadth. If I draw that parabola and the double ordinate, this is the parabola which we have taken here, and the double ordinate, let me take, this is the double ordinate, this is a b point, this is, let me take a point, and this is b dash point. Okay, no problem. This is origin, this is x axis, this is y dash axis, this is x dash axis. Note the double ordinate, this is the double ordinate here, b dash is the double ordinate. The equation of this we have taken as b from the vertex, the distance of this point A or this double ordinate b dash is b, x equal to b. Here we have taken this equation of the double ordinate. Okay, now we have to find out, we have to prove that what is the area here is let me take the area of this whole parabola cut by this double ordinate is to be proved to whatever is this. This is, let me take delta x or dx. This is dx. This is p q we have taken. Okay, p m and n. This is the point here. Now if I take the distance of this ordinate, now this is the ordinate. Let me take the coordinate of this is, here it is b. Let me take c point here. This height is c. What are the coordinates of this b point? This is b and c. Coordinates of b are b and c. Okay. Therefore, the height, this c, we have taken ab as c. So the total height of the double ordinate is twice c. This is simple, because here x equal to b, here x coordinate is b, y coordinate I have taken c. Okay, so in that way, or if I take, let me take this as by here, because it's a by coordinate here, because equation we have to convert the equation of the parabola. Y square equal to 4ax, so we have to substitute finally that this point will lie on this parabola, this b and this point. Let me take here by 1 or by 2 we can take. This is by 1 here, so this is by 1 here. So distance b here, b a b dash equal to twice by 1. Distance, total distance of double ordinate or length of the double ordinate. This is not a distance but total length. Total length of the double ordinate. Total length of BAB dash double ordinate. Let me take double ordinate is or B BAB dash is equal to twice by 1 here that we have taken, because this is in terms of by, because we have to finally replace this because this point is lying on this line. Then we have to find out what is the area of this rectangle double ordinate, and this is the breadth b into twice by 1 is the area of the double ordinate. But this by 1 finally we have to substitute from this equation. That is the question here. So now solution. So what we have to do here, we have to prove here, what we have to prove that the area of the double ordinate, it says so that the area cut off by the cut off a parabola by any double ordinate, okay, by any double ordinate is 2/3 of the, so area is, we have to find out area of BOB dash, this BOB dash, total area of this okay, of this parabola cut off by double ordinate is equal to 2/3 of the area. We have to prove that is equal to the twice 2/3 of the corresponding rectangle. Area of the corresponding rectangle This is again this total area. If I find out this rectangle, suppose this is the rectangle here, so height, this breadth is b into twice by 1. That is twice by 1 into b. This is the area. Twice of this will give us this area. Okay. So this we have to prove here. This we have to prove. We have to prove here that the area of BOB dash, total area cut off by of a parabola by double ordinate, is equal to 2/3 of the area of the corresponding rectangle. That is, this is the area twice by 1 into b. Twice by 1, why? Because length of this whole ordinate is twice by 1 into b is the breadth. So length into breadth is the area of a rectangle. So this is the area of the rectangle. This rectangle's area, or 2/3 of this area, is equal to area of this cut off area by the double ordinate. So let me find what is the double area of this, okay, cut off by BOB dash or double ordinate. So area, okay, area of BOB dash is equal to, if I take this area only, the upper area, that is OAB, equal to twice into area of OAB, twice of area OAB. But this is equal to twice into integration of limits from 0 to B here, because this is B point. This is B and 0. A point is B0. B we have taken 0 to B. Okay, this is the area. And now area of OAB, this area is by into dx. By into dx, but by is equal to that value, so we can substitute this as twice 0 to B. What is by here? By is square root of 4ax into dx, as since y square equal to 4ax and y equal to plus minus twice under root ax. So y is equal to 2 under root ax, we have to substitute here. This is nothing but 2 outside, taken outside from this is 0 to b under root a is also out taken, and this is x raised power half into dx. Okay, so 4 under root a, this is equal to 4 root a square root a into x, integration is x raised power 3 by 2 upon 3 by 2 means 2 by 3. This is 2 by 3 into 2 by 3. Okay, and then limits 0 to b. So this is nothing but 8 by 3 under root a into b raised power 3 by 2. This is the area of the, here under root a is the a from this parabola. Okay, and b raised power 3 by 2 is the value of this distance of a on the double ordinate. Double ordinate is b a b dash from vertex o. From vertex o, b is the distance here. B raised power 3 by 2. This is the first equation, or let me take this is the first equation. Let me take this is second equation. We have obtained this value. Now let us come to next topic which we have to prove. Therefore, this value we have obtained here is, let me write here, this value is equal to 8 by 3 a raised power half into b raised power 3 by 2. This is the area of this, okay, parabola cut off by double ordinate. So this is the second equation we have taken. Now area of the rectangle, okay, made by double ordinate with this one. So this is equal to, and now 2/3, okay, or 2/3, let me take 2/3 of corresponding area of the rectangle by cut off by double ordinate. So what is that? Let me talk about. This is 2/3, 2 by 3 of area of the rectangle cut off by, or made by, cut off by, this is made by, area made by the double ordinate, rectangle made by double ordinate. Okay, so this area, as I just talked about, by double ordinate or double ordinates, this is nothing but 2/3. Now this area is twice by 1. This length is BAB or BB dash. This is BB dash here. So BB dash is equal to twice by 1 are taken. By 1 is the this height of this, I mean coordinate by coordinate of B. By coordinate of B, twice of that is twice by 1 into B. Now by 1, but this point B by 1, but B, that means B by 1 lies on first the parabola, lies on the parabola. So it will satisfy it. So it will satisfy it. So it will satisfy it. That means we have to substitute this point B by 1 in this equation. That means by 1 square is equal to, in place of by we have to substitute by 1, and in place of x we have to substitute B here. This is equal to 4AB. So y1 is equal to twice under root AB. This is twice under root AB. Now here B we have taken. Okay. This is twice under root AB. So these are the two lengths here. Now if I substitute by 1 here, we will get 2 to the 4. This is 4 by 3 into 2 to the 4. By 1 is this twice under root A into under root B, but B this is there. It will give us the same value as we have already calculated. So this is nothing but 8 upon 3 A raised power half or under root A into B raised power half and 1, that means B raised power 3 by 2. So this is the area. This is third equation we have seen. So from second and third, we see here the result is the same. From second equation and third equation, we have obtained that the area cut off by the double ordinate from the parabola is this, and this is the area of the rectangle made by this B length and this height or this length of the double ordinate, which is twice by 1. Is this much the same value? This is proved. Hence, from second and third equation, we get that this is proved. They are equal. So, what is this? Hence, it is proved. They are same. This means we have proved that the area made by or cut off by double ordinate from the parabola is equal to that value. Okay. Now let us discuss about next thing. Okay. Now let us discuss about next question. Now question number 11. Let me discuss now question number 11. Question 11 or 11th question says that trace and find the whole area of the curve. This, what is the curve? AQX square equal to, this is the YQ into twice A minus X, Y. This is minus by here, I'm sorry. Minus by here. So this is 11th question. Trace and find the whole area of the curve AQ X square equal to YQ into twice A minus Y. Alright. So solution. From this, what do we see here? Here this equation is symmetric. First let me trace the whole curve. This curve is symmetric about y-axis. Why? Because x square is even powered. Is symmetric about y-axis as x is even powered. Variable x is even powered, y is q and y is square by 4 it may be, but here yq is also there. So It means it is all the terms of y, if are even powered, then it will be even powered. Here x is the only one term which is even powered, so x is even powered. Because of that, the curve will be symmetric to y, or symmetric about y-axis. If y is even powered, then it will be symmetric to x-axis, but in this case it is symmetric to y-axis. Simple. Second point, will it pass through the origin? Yes, it will pass through the origin. It will pass through the origin. It will pass through the origin. Why? Because there is no constant independent term. As no constant independent term. No constant independent term. Okay, is there or is absent here. Third point. What's third point here? So we have to equate x equal to 0. So x equal to 0 will give us. So x equal to 0. We get here what are the points. So the curve will meet this curve will meet the y-axis in this case. Y q into twice a minus y equal to 0 implies that y equal to 0 and y equal to twice a. So the curve will meet the y-axis in this case. Meet the y-axis. Meet the y-axis at first 0 0 because that's 0 y 0. Second point is 0 x 0 and y is twice a. At these 2 points. Now shifting the origin to 0 twice a. Now shifting the origin to 0 to a. We get, this is equation aq x square as it is, because a plus x plus 0 is x square only, equal to, now this is y plus 2a whole cube into twice a minus y minus 2a. So this is nothing but minus 2a minus 2 cancel out. This is minus y. Negative value is this. This is minus y into y plus 2a whole cube. So what do you mean? This is, sorry, x square is negative here. Here a cube, x square is negative. What does it mean? Here x square is negative. X square is negative. So the curve will not exist beyond y equal to 2a. Y equal to 2a, beyond y equal to 2a, the curve will not exist here. Okay, so if I just solve this equation, so from that equation y, because this is all y cube, x equal to 0, so by equating smallest degree term, smallest degree term to 0, we get x equal to 0. That means the new, here x equal to 0. Sorry, here it is y equal to 0 because this y is the smallest degree term. I'm sorry. Because here 2a cube will be there, so y equal to 0. I'm sorry. So y equal to 0. Here y minus y into this 2a whole cube, that means 8a cube into y, that will be the smallest degree term. I'm sorry. So y equal to 0. That means the new x-axis, the new y0 is on the x-axis. The new x-axis x-axis will be the tangent line, will be the tangent at 0 to a, okay, or will be tangent at 0 to a. So what is the curve here? Let me draw the curve now. So equation, therefore finally the curve is, let me draw the curve now, or trace the curve here. Let me plot the points here. So what is the curve here? Let me change this marker. Marker if I change. Okay, curve. This is the x-axis here. X-axis is y axis. Now here at 0, 0 and y equal to 2a. Now this is the, okay, here y equal to 2a, so 0, 2a. And this is the new x-axis which is parallel to the old x-axis or original x-axis. Okay, this is the tangent line at which y equal to, y x equal to 0. At this x equal to 0, x equal to 0. So new x-axis, this new x-axis here, on the x-axis y is 0 undoubtedly, but x-axis which is parallel to the original this is the tangent line or new x-axis. New x-axis is the tangent at 0 to n. Now area we have to find out here. What is the area then? Let me take this smallest strip. The strip here is this. What is the area here? Limits are 0 to 2. So this is 0, 0. Okay, and this is suppose P point, and this is M, N, delta by here or d by. This height is d by, and this is PQ. No problem. And this is, let me take A point. So area here, area of the loop, this is O point, OA, O dash, OAO, this is OAO. We have the required area of the loop, the area of the loop, required area, let me take. Therefore the required area of the loop OAB we have, or is equal to, let me write here, is equal to twice into this area of OPA, the smallest one. This is area of OPAO. Okay, the half of this into twice of this. This is twice of this. What is this area here? And this area is twice into 0 to 2a limits. This is x into dy. Here x is to be substituted from that. Okay, let me find out the x value here. Finally, we have x equal to twice into 0 to 2a. Here x square is equal to this, so it will be by raised power 3 by 2 into square root of twice a minus y upon a raised power 3 by 2, because a cube will come in the denominator and x is equal to this. So x equal to plus minus this value, but it will be plus sign here. So this is d by x into dy, because this is along the y-axis. Y-axis here, okay, is a symmetric axis, or the curve is symmetric to the y-axis as we describe here. This curve is symmetric about y-axis. This curve is symmetric about y-axis. This is symmetric about y-axis. Okay, the area. So therefore, this variable differential integration of variable is by here. So the dy is there. Now let me take this further. So this is 2 upon a raised power 3 by 2. Okay, now y cube by root equal 3 by 2. If I substitute y equal to, let me put y equal to 2a sine square theta. Therefore dy is equal to, so this is 0 to twice. Limits are 0 to twice, so this is dy equal to, therefore twice, differentiating with respect to theta, differentiating it with respect to parameter theta here. So 2a, sorry, this is 4 now. 2a into 2 is 4. A into sine theta cos theta into d theta. Okay, now limits here. What are the limits here? At 0, lower limit is 0, but at twice a, at y equal to 2a, okay, sine theta is equal to 1, okay, or theta is equal to pi by 2. Simple, because 1 is in sine or sine pi by 2, so theta equal to pi by 2. At 0 it is 0. At y equal to 0, lower limit. When y is 0, the lower limit. And what is theta here? Because we have to convert in the new variable, everything into the new variable. So this y is 0, then theta is also 0, and theta is also 0. Because sine square theta equal to 0, y is 0. That means sine theta is 0, sine 0 is for sine 0. So angle is 0 here, so theta equal to 0. So 0 to pi by 2 are the limits. Let me write it here. So finally, let me put the whole value here. Therefore the area, required area, so required area is equal to twice into, okay, this is 0 to pi by 2. Here it is 4a sine theta by theta, but in place of y we have to substitute 2a sine square theta. This is whole power 3 by 2, because by 3 by 2 is out of the square root, and under the square root it is twice a minus twice a sine square theta, and out of the square root we have 4a sine theta cos theta into d theta. Okay, so this is the required values. Now let me check whether any mistake. No. Okay, so limits are this. Now let me finally multiply them. Therefore the area of the loop, okay, which is formed symmetric, which is about symmetric about y axis.